Hello, it's Bart from Nature Manufacture. This time I would like to show you our river auto material C object. Let's maybe create such an object. You create it like a normal C object, so 3D object, Nature Manufacture, create like polygon. With control, you place points. Let's maybe move it a bit up. When you're placing points, try to catch the shape of the terrain and intersection, because all data for the C object is stored at triangles. And if you will simply place triangles under the terrain, you waste triangles that could hold the information of your C. And it's simply waste of the rendering, because you will have to place more triangles, bigger density to get more accurate data. And you spend triangles under the terrain, which is useless. Okay, now let's drag and drop our C profile. Let's turn on LOD, and we got the C object. But what is the main difference between C object and typical lake object that we have in our system? First of all, you have a material, tessellate or non-tessellate, it's up to you, which read additional data from the mesh. And this additional data is depth, so the distance between water surface and collider, because it could be, for example, any other object. Wave curve, which is responsible for stretching, rotation, the waves near the shoreline. And directional map, which is responsible for distribution of the waves around the object. And these three values, of course with adjustment, is mostly responsible for everything that you have on this screen. So wave propagation, their height, their type, and so on. Okay, so let's start from the mesh settings. More triangles you will generate, more data, and better resolution of the C object you will get. You have two values here, the max triangle amount, so even if triangles will be very small, it will not cross the triangles amount. So in this situation, simply triangles will be bigger until it hit the maximum triangle amount. So this will block situation when it will generate huge mesh with huge amount of triangles. You have a spline density, but for C object it's not super important, because mostly every edge of the C object will be hidden under the terrain. But we could, for example, reduce it. It will be more rectangle shape. Let's maybe play with the I will show you what is the difference when I will put the bigger resolution on this object. So I will reduce triangle size. And what is the difference with quality of the mesh and effect? So let's maybe reduce the triangle size to, for example, 5. First of all, it will generate longer generation process, but you see that the waves are more smooth. You have a more triangle, much more effects could be done, much more shapes could be cut. If I will, let's maybe reduce this resolution of the mesh, so increase the maximum triangle size. You see the resolution is low, and if this will be super high, it starts to ignore some data. So, because there will be no triangle that will give information that there is a island here, right? Or any other object. So, the more information about the terrain shape you have on the C object, nicer effect you will get. That's why I told you to do not waste the triangles under the terrain. I will show you some tricks later in the tutorial about how to generate huge meshes with nice waves. Because the thing is that we store every data about the terrain under the object in triangles. So less triangles you have, less data you have, so more noisy effect you get. So that's about the triangle amount and size. Depth curve. Basically, it's a relation between the distance from water shape, mesh, to terrain and how we save it. At the moment, it's linear, so at 0 distance you have 0, at 60 distance you get 60. We highly advise to do not change this because, for example, if you will set up a material that you change wave to shoreline wave at depth about 5 meters, if you will change this 5 meters will be, for example, at 6 or 8 meters or 2 meters. It depends how you will change this curve. Wave curve. This wave is responsible for stretching of the waves in a different moment. For example, at 7 meters, there is no stretching, so no water swash. At 3 meters, so the 3 meters between sea object and terrain, we start small swash, so waves start to stretch a bit, and then there is a final swash when the water meets terrain. Basically, the swash value in material, read this curve and multiply it. Let's increase the swash value in the middle of the sea, so we'll see what's the effect, and you see that all waves become stretched. If we will reduce this to normal value, we get pretty nice effect that wave become pushed by wind a bit. So this will help you to this curve will help you to achieve all results that you would like to get. Okay, so the directional map. Directional map is mostly used in polar waves, so they accent the shape of the terrain and collision with water. If we reduce the smooth amount, you will notice that in a place where the waves start to flow in a different direction, we could get a noisy effect. And without smoothing, you will not solve this. If we increase the smooth amount, the problem has disappeared. But you also lose some data from terrain. So look, for example, at this place. At the moment, we have a bigger smoothness. If we reduce it, we get nice shoreline waves which push water into the cliff. Yeah, this effect is pretty nice, but we have a broken part in other place, so you have to adjust that to your map. Smooth distance. First of all, I open our coast and use demo scene where we use our C object to show you what is the difference and how big it is with smooth and without smooth distance. Let's turn off the smooth now, and you may notice that everything is noisy here because of these objects. They have small colliders, and of course you could place just colliders for our C object and at specific layers, so only C object will read it. But you could use this kind of small colliders as well. You just simply set smooth, turn on the smooth distance. So in fact, it will maybe not ignore, but it will smooth this kind of small changes. The same is with terrain under the water. If it's noisy and distance to the shoreline for polar wave is noisy, if you turn on smooth distance, it will handle the situation for you. So this object is taken into account, but it doesn't affect so much the water surface. Same situation we will have here, because if you have this kind of shape without smoothing distance, you will get polar waves, shore waves into every direction. So these waves, you have a sea which have this direction, and it push water into this place, and this kind of waves are improper. If you will turn on smooth distance, these waves will be more directional, you see, and the result will be much better. Of course, it's also related with directional map, smooth amount, and so on. So you have to find good result for your current material setup and terrain shape. When we generate polar waves, we raycast from each point in the direction to the nearest shore line. And by decreasing rays amount, you could speed up sea process generation, but you decrease the resolution of this process. So you will reduce the amount of rays per angle. If you will reduce the rays angle, you will simply ignore some directions. So it will ignore, for example, from that point, it will ignore this island. Remember that you have a optimization, the LOD. Let's maybe go to the offset material and let's turn on the triangles. Let's turn off the LODs. So that's the triangles of the C object. Of course, this C object doesn't need this amount of triangles. We could, for example, reduce it like that, or even like that. And now if we turn on LOD, you might notice that we generate triangles in 4 stages just to distance to a camera. I showed that on non-tessellate material because if you would use tessellate material, so it's for HRP and built-in, you will get additional triangle density just because of the tessellation, right? So you get another stage. But remember, if you use LODs, it increases the triangle amount, so the waves will be more smooth and so on, right? But it don't generate additional data. So the basic data, so the depth of the water, shapes of the terrain, is saved at this basic triangle amount. It's only responsible for the waves propagation, but the waves shape and their triangle amount, so how smooth they are, how detailed they are, you could improve by LOD system. In same way, you could use pretty simple mesh in a far distance, but it will only generate triangles and improve its quality close to the camera. I get huge amount of questions about how to handle big water shapes with these systems. As a first step, I will show you the wrong setup. I mean, it may be wrong for most cases. So you generate huge water body with huge amount of triangles, and the resolution of such a mesh is pretty low, and the waves are, I would say, they are not detailed, but maybe for some cases it's enough to hold such a mesh. We set up generate LOD system to generate LODs in a very far distance, because simply if we will look on without the LOD system, if we look on the body, the quality is super low, so it may not, maybe this way, it may not catch the shape of the terrain, because there is not enough data to generate nice waves, right? We have only 2 points or 3 points, and the value is interpolated between them. If we turn on LOD system, it will only place some triangles just to generate waves, but the data will be still not enough. I mean, of course, it could be enough for some cases. Even at this wrong setup, we made a trick. We made a simple spline object. So we click 3D object, which will create simple spline. We set up it on the same height as a water body. It's important. And by this object, we could water triangles under the terrain. So we use the lake holes object. Simply drag and drop this object here, and we could water body from under the terrain. So these triangles, which would simply be empty and generate performance overhead, become good, and the triangles which we want to spend on the water body, we use around the island. But like I said, this is wrong setup. There are much smarter options. Let's maybe do this. Let's turn off this, and let's turn on the sea layers object which are prepared. And what we have here, first of all, we have an object of the sea which is smaller. It's the object which only gives nice views with good resolution in a close distance to our island. It become cut by the island occluder, so simple spline as well. But you may notice that this object is much smaller than object I showed you before. And so with the same triangle amount, we have a much better resolution near shoreline. So all these waves have proper propagation now. So all these islands, small islands around, get proper waves. But for far distance, we generate very low resolution, but very big water body. So it will fill the horizon. It's only about 1000 triangles, but it become cooled by this more detailed body. So we have I would say layers. We have a huge water body which will fill the horizon around the island, and we have a detailed water body which is detailed only in a distance that is visible, and it generates nice waves. You may notice that if you look at this body here, there is no visible line of the two water shapes because it's very far. How big are these water body shapes? Basically, the huge one, which I showed before, was about 16 kilometers square. So probably Unity will not handle bigger maps with than 2 by 2 kilometers. So this kind of shape, which is 4 by 4 kilometers, it's enough to cover the horizon. These layered bodies are, for example, if we look on the points, we will probably see almost 2 by 2 kilometers. So this detailed body is 2 by 2 kilometers, and this background is about, let's go to the points, about 10 by 10 kilometers. It could be endless, I would say. It doesn't cost anything. It have a very low triangle amount. It's only a background object. That's why I said this setup is much better. And with the same triangle amount, layered option and non-layered option, the difference on quality of the waves is huge. You see that there are some artifacts, but the shoreline is not well detected. Layered option, shoreline is detected, and the waves take it into account. For this kind of big maps, I would rather use layered option, and of course you could increase the amount of triangle for this water body, but probably it's not worth to create huge triangle amount just for one object. For the material setup, I will back to our original Review Auto Material tutorial screen, and I will play with all these values step by step for you. First of all, we have a mine global tiling, so you could increase or decrease the tiling of the textures. But I suggest to keep 1 because it globally changes the tiling of the textures, and noises and so on may just be broken. It will noises that work nicely for a big tiling probably doesn't look nice at smaller tiling, so I would say it's good to hold this at value equal 1. UV direction basically give you ability to rotate the UVs of the textures. It's just a texture rotation. It only rotates the texture, so it doesn't affect any waves and so on. And you have a mine water speed and wind mix speed. If you will increase the speed, you will notice that the normal maps of on the water will simply move faster, and all foam effects as well. Wind mix is a value which rather should have an opposite direction than the water speed. I would say it should rather have direction of the wind, because even on smaller water bodies, it may happen that wind push water surface, only the surface, so the top layer of the water, in the opposite direction than water moves. And this effect, first of all, give you noise effect on the normals. but also give you effect of the realistic water behavior. So the top of the water moves in a different way than water body. You have a water flow UV refresh speed, which is basically maybe at this C object is not really important because it's responsible for flow map refresh. And with higher values, you will get super fast flow map refresh, which will be super odd. With lower values, it will get nice effect, but texture could be stretched if the speed difference will be big. But as this is an C object in flow map, use a directional flow map. So the flow map is the global flow map on the water body is in one direction. Then this doesn't have so big matter because there are no flow map changes. C object doesn't support flow map painting. I mean, of course you could paint flow map on it, but it will mess the shader. Maybe I will break this for you. You will see that if the direction is opposite, it starts to generate lines. If I, for example, use smooth, let's increase the blend size. Let's decrease the opacity. You will see that Simply Shader do not accept flow map because C shader get directions from the other settings like depth and directional map. So it does not support flow map. Of course, you could increase the height of the C body. So you get nice, you could bump the wave in a specific place just because, but it will be static. So the height vertex painting is probably also useless, but maybe you will need it, for example, to accent some shoreline on the of the terrain, right? It's not natural, but just for artistic result, maybe it could be useful. So let's reset this water body now. Let's reset flow map. Let's reset height. When we have a terrain on the other side of the map and we want to set the other direction of the C object in mesh painting, in flow map, we have a directional flow map and we simply set it to different direction and we click generate. Right? You could set every direction. Basically, it's a wind direction of the on the water body because waves comes from the wind, and you set up the water direction by this values. Okay, so let's talk about polar waves. First of all, let's clean all other waves so it will be more visible. We left only polar waves now, and you have a few options to adjust them. First of all, it's the depth when they appear. It's the depth from this depth curve. That's why I said if you will change this curve, you could get a false setup on the material. So we could, for example, use only polar waves, and of course you will get noisy result in the place where they start into different direction. You could readjust that with directional map smooth. let's maybe set up it again to 7 meters. So only 7 meters on 7 meters depth they will start to grow. And you could set up where they become flattened. So at which moment they will become flat. So they broke and swashed the terrain. Basically broke, become lower. And for example, you could do this at 2 meters or 4 meters as well. So wave which grow will simply become flat at 3 meters, right? Water depth. It's mostly visible here, right? Okay, so let's set up this to 0.4 meters. So they will become flat about half when the water have a half meter depth. And correlated values to polar wave depth start and flatten point is polar wave height, because you set up how high is the wave at 7 meters. So you could, for example, set 0 or 8 meter. And how high is the wave when it becomes flattened. Maybe if I will play with this wave scale value, it will be more visible through that it change the height near the shoreline, right? And now you have a wave scale. So beside it's also the height of the wave, because the bigger wave is, the height is higher. It's also how often the wave will appear. Let's maybe reduce this. You see that we have a bigger amount of smaller waves, but when we increase these values, we have a less waves, but they are bigger. And remember that if you set up, let's maybe turn off always refresh. If you set up too big height but too small size of the wave, they will start to intersect. We built in a shader multiple systems that decrease or block this situation, but it may happen that with extreme values you will get intersection effect. About the polar waves, there is a cool feature which called polar wave silent area angle. So what does it mean? Without let's maybe first of all turn off the noises, all noises, so everything will be visible out of the box. So small noise multiply, because small wave noise multiply is also responsible for the polar waves. So if we change the polar wave silent area angle, you see that the waves that are behind the islands disappear. So this is kind of a terrain shape shadow on the waves, right? It's proper, and this is a physical result, because if you have a wind from this side which push the waves into this direction, after this island there will be small silent area, because wind doesn't have a speed yet to push the water and generate waves again. That's why you have an option to adjust that. You have also hardness for this, so you could, for example, set up kind of value and make it more sharp or not, right? See, you have a sharp result. Okay. What next? Next, you have a swash size. So basically, the swash size is responsible for the C swash. Let's maybe, for now, let's bring back the noise. Okay. And let's back to the swash. What basically swash do? Swash will stretch the waves into the shoreline, and you have this by slider. If we increase this, it will start to stretch our waves, right? If we turn this off, it will be less stretched. And this value is reading the wave curve. That's why we have no stretch, no swash in the middle of the sea, and we have a swash effect on the shoreline. And we noise that a bit just to get some non-repetitive image. So with this swash value, you could create nice shoreline effect, but remember that if you will set this value too high, you will start to get bad looking results, and normals will be broken and mesh will start to intersect, especially when you have a polar waves, small waves, and shear waves, and all these waves are added together to get to give you the final wave result. And if you will set up swash too big and they will add together in a specific place, you will get pretty odd effect. Okay, so that's all about the polar waves. Now we will turn on the small waves. So basically, small waves are directional waves, because polar waves are polar. They always move into direction of the collision, the terrain or object. But small waves are directional, and they will add to the polar waves to generate nice effects, which comes from the wind direction. So let's maybe turn on the small waves. There are two layers of the small waves. Always try to set different height on them just for additional mix. We could, for example, for a moment turn off the polar wave. We don't need it. Like I said, never set it to 0, but okay, let's do this like that. Let's turn off the swash of the polar wave for a moment, and we have only small waves. And what setup we have for small waves? First of all, we have the same setup like for the polar. So when they start and when they break, right? If we set up, they start from 3 meters and they break at 2 meters. You may notice that it will break them in a specific depth. It's also related to depth curve. Okay, but first of all, the small waves, I would say they are always. The difference is that you have a small wave show a height multiply. So if you will, for example, set up small wave's height to 0.3 and 0.1 by small wave shorter depth start, you may notice that if I change this, waves start to grow but only near the shoreline. So what's the idea? Small waves are always just because we want to mix sea waves. But with this shorter depth start, we start to multiply the wave height when it's near to the shoreline. So you have a small wave shore height multiply. We could set it to 1. You will see that there is almost no effect. But if we set up it to, for example, 9, if we change this, there's a big effect on the waves. So we multiply the wave height when it's so the wave is grow when it's near the shoreline, and it's also physical effect because wave just become pushed by terrain higher and it start to breaking. And this breaking effect you could set up in small wave flatten. So first of all, flatten point where this break effect appear, and flatten height, so how high the wave is after it break. Maybe. Right, so how high is on the shoreline. You see, if we break the wave at 2 meters, we could set up the height of the wave after it break. Okay, and now with small waves you have an additional value, which is direction, and let's maybe set up house to okay. Direction. So because the small waves are not directly from the wind direction, so the water direction, but it's from you get noise effect. So if you will, for example, set up 90 degrees, you will get such a result. If I will set the same value on this direction, you will get straight lines. If I will start to rotate one wave will come from this direction. If I will start to rotate second wave maybe on the opposite direction, it will be more visible. The second wave will go from this direction. There is a small wave house. By this slider you could reduce or increase this effect without changing these two values, right? You see that without any house value, you will see that if I set up 20, I get 20. If I set up 0, I get 0. And if I set up 90, I get 90 degrees. If I will move this to lower value, it will start to decrease this direction value. And of course, you have a wave scale. So this is the scale of the waves. The situation with the silent area angle is exactly the same like with polar waves. So this by this value you could hide the waves, the small waves after terrain object. And I would say while the polar waves shouldn't have a big silent area angle because there are always small wave which will even go in opposite direction to the wind, the small waves which are directly because of the wind should have this silent area angle. To avoid this kind of situation, without this option, you will get waves which simply spawn behind the terrain. It's unnatural. When you increase the silent area angle, they will appear but in a longer distance from the collider. Okay, the same as in polar waves, you have a swash size, so you could set up swash of this wave. Exactly the same situation. It depends from the wave curve. It becomes multiply by it. That's why with even big swash value, you don't have this effect on the deep water, but it becomes visible near shoreline. Also, I advise you to do not set this value too high because you will get intersection effect. That's maybe on the waves, right? With too high value and too small depth size of the wave after it becomes flattened, wave will become stretched and generate mass and intersection. Okay, and the last wave is the sea wave, and let's maybe turn off the small waves now. 0.1, so super small, and let's increase the sea wave height. So now we have a sea wave which will only be visible on the deep water, and you have a setup here for when the sea waves should start to become flattened and when it becomes flattened. We don't want to see waves near the shoreline at all because they are big, and they are big because the water is deep, and it's possible to generate such a big wave at deep water. And when they are closer to the shoreline, they simply disappear and other waves start to appear. That's why we rather keep these shorter waves in a longer distance from the shoreline. And this is also reason why we should have a noisy and non-flat terrain under our sea object, because even such a small bump, right, will generate noise on the sea waves, and these sea waves simply become non-repetitive. So we have a sea waves height, their flattened size after they meet the flattened start border, and of course direction like in small waves, and house for this direction. And what more we have for all these waves? We have small waves, which is for polar waves and small waves, noise, and CA waves noise. Basically, you have a noise texture, which is tiled separately for small waves and separately for CA waves, and you could set up this noise influence on the water surface. It's mostly responsible for killing the tilting of the waves on the area that is flat or there is no information from the terrain. So to avoid situation when the waves are super repetitive, because the terrain under the waves do not affect them at all, you could noise them with the noise sliders. If you will turn on the other waves, polar wave as well, you could see that beside that, because of the mix of the waves, we get non-repetitive effect, because we have small waves, polar waves, CA waves, and they are mixed together, and they get information from terrain, so they are mixed additionally by terrain. But beside that, you have a noise effect. Let me find this. You have a noise effect which may simply kill some tilting that appear. Remember that when you increase the noise power, you also decrease the power of the height of the waves. So if you will set up waves height on no noise setup, this wave become lower when you will simply add a noise. Yeah. Okay, so we break this shader a lot. I mean the material, because but since we finish the whole shape of the water body, so the waves, and we could talk about the effects of the water, like alpha, color, and foam. Okay, let's talk about the water color and options on the water materials. First of all, you have a alpha edge multipliant power, so you could make the water sharp intersection with terrain or any other object in the background, or you could decrease that effect. You have a power for this effect, so with these two sliders you could achieve almost every effect. You have a alpha global power and alpha global multiply. And basically they behave the same, but they have a different meaning, because alpha global multiply also beside that it may show up the background of the water even at deep water. You see, it also I would say reduce the color of the water on the shoreline line. I mean, you see that if I decrease the global power multiply, we get more background than color on the shoreline line. But if you will decrease this too much, you will start to see the water background even at deep places. Okay, like with Edge, you have a multiply and power to add to get every kind of result. The next step is that you have a alpha backface, but it's only visible if you will use a two-sided. For two-sided materials, let's maybe turn on the second side. For two-sided material, you could improve or decrease the alpha of the water. But for C object, I would rather don't use double-sided, because it may generate some issues of shorter line. Okay, so we have a backface alpha. Let's back to the colors. And now we have a clean water options. First of all, what is clean water? It's available at URP only if you turn on options about opaque textures and so on. So in fact, you will be able to render texture from the transparent object background. Let's maybe set up some values which will highlight this. So you could change the color of the background of the water. In most cases, probably you want to reduce a bit brightness because the background is wet, because it's underwater, and that's why it should have a lower brightness. It's also color of the, I would say, distorted image, because clean water is a place where the distortion mostly operate, and you could adjust the distance of this area. Maybe let me turn on the always refresh. You may notice that we have a distortion here, and if we render only a clean water, we see the distorted area only, and this we could reduce or increase the brightness of this distorted image. Like always, you have a multiply and power values to generate sharp or nicely lerp effect. Okay. It seems I break this material a bit during the setup, but the another option you have is a shallow and deep water colors. By shallow fall of multiply, you could set up when the how deep the shallow water is, with the same with power function, how sharp the transition is, and with colors, of course, you could change the shallow and deep water colors. For example, we could set this like that. Okay. With water normal, of course, you could set up the normal map of the water, and this is maybe I will give you important tip about that, because if we, for example, for river and lake objects, we have pretty low density of the triangles. At the sea object, density is pretty high, and we should less count on the normal powers from the textures, but the more important should be the shape of the water body. So the main normals on the water get from the triangle density and its body, you should get less information from the normal maps. So the normal maps should be rather smooth. And that's why all these values are pretty low. And that's why the water still looks like it have a shape, because this shape comes from triangles. Of course, if you use mobile shader, you will rather count on water normal texture than a water shape, because you will have a less triangle amount, and you will not be able to get nice shape of the water without the normals. Okay. And for the normals, you have a micro tilling, so the microwaves, let's maybe increase them. You could see that I changed the microwave tilling. Let's reduce its power. You have another layer which is called macrowaves. So this is the macrowave and macro wind waves, which probably should be the biggest waves, right?
Right.
Let's maybe even read it. 0.1, for example, like that. And of course, you have a water tilling, so normal water, normal tilling, which is correlated with all high maps and effects. And so this is just the tilling of the normal water effect texture, which moves with the body of the water, because it's pretty important that the micro and macro waves and the normals are designed to move with a wind, and probably in opposite or maybe a bit similar direction to water body. So wind micro and macro waves are just used for mixing of the water normal body, while the normal water scale is just a water body. Okay, and now we have a first option that appear only at shoreline. So you see that we create swash, so we flatten the waves near the shoreline, and with this multiply we simply also flatten the normal maps as well. It will be more visible here. If we go to the flatten normal multiply, if I will set it to, for example, 10, you will see that we have first of all, we have normals which are strong under the waves and near the shoreline. If we will set up it to 0, we have a smooth water on the shoreline and smooth water on the wave curved area, right? Let's maybe turn off the always refresh and see that if I will increase this flatten normals, this flattened normals start to appear first of all under the waves and on the shoreline. So this value is used to generate nice swash and shoreline effect, which first of all it will only flatten the water normals, so the foam normals will be as they are. As I told you that normals under the waves also become flattened, because it's also physical accurate that this water become moved from down to up and become stretched. So normal should be, I would say, become flattened. You have a slider to manage this, so you could simply reduce this effect on the waves if you don't like it, but you will get stretched normals on the waves because we stretch the water body, so the normals on this water body also become stretched. So you have a mask power for this effect. You see that you could reduce or improve the flatten effect on the waves, and of course with the water normal multiply on the shoreline. Another thing is that in a far distance we rather want to have a flattened normals because our eyes are simply not able to see all the small difference on the water in a distance, and we also want to get smoother reflections in a far distance. That's why you could change the flatten multiply by a distance. So you have a far normal power and far normal blend start distance, right? So you could set up when this normal flattening effect start to appear. You see that if I will hold sharp normals in a far distance, simply image on the water will be noised until the horizon, and it's not something that we want to hold. You have also threshold for that. Okay. The same situation we have for smoothness, because we could set up different value of the smoothness in a close and a far distance, and in fact it's also physical aspect that water have a higher smoothness value closer to our eyes and lower smoothness value in a far distance. It's also useful for managing the reflections and the glossiness of the water. Because if we set up too low value, if we set up the same value of the smoothness in a close and far distance, we get such an effect. Like it become more plastic than a water. But the same high smoothness value in a far distance will simply reduce the glow, sun glow effect. Exactly the same situation you have with specular, but we will talk about it a bit later. Now about foam smoothness. You see that you have a separate slider for smoothness for foam effects. You have, of course, ambient occlusion setting, but water ambient occlusion is always 1. But we leave this maybe for if you will create a more swampy, or you just want to reduce ambient occlusion color on the water, you could reduce it. And with specular there are more options, because first of all you have a specular Fresnel effect. So it take wave angles and propagate specular in relation to them. So on the waves, the specular will be reduced, while it will be higher on the flat area. You also have a specular distance, so you could set up different specular for close and a far distance, and it's also related to the reflections and the glossiness of the water, because in a far distance we rather want to have a higher specular to reflect more from the sky, but in close distance, if we will increase the specularity, we have the same situation like with smoothness, so water become plastic. Look at the values that I said. I set a very low value on close distance, but very high value in a long far distance. If I will set the same values on close and far distance, water will look simply wrong, or it will lose some effect. So that's why the same specular value for close and far distance will not work. So basically, the mix and max value is used in Fresnel and in a distance. We also add specular depth, which is used to, for example, override in a far distance. We want to override the high specular value which comes from a distance, just because the water is not deep. So you could also reduce the specularity of the water because of the water depth. Same situation like with Fresnel effect and smoothness close in a close distance, because if water is not deep, we rather want to keep lower specularity to avoid plastic effect or sharp edges. So that's why you have a control over the specular by depth. And of course, as you have a foam smoothness, you have a foam specular value as well. If you use HDRP, you also have a subsurface water settings. Okay, so you could set up subsurface profile to the water. It's used for scattering and translucency effects. In URP water, we replace that by sliders. So the same effect like you have in HDRP, the translucency effect you could achieve with sliders at URP. Of course, you have a foam color, so you could improve the foam color, right? But the foam is this is the sea foam. So this color is about the foam in the middle of the sea on the sea waves. But we have separated colors and effect for the shoreline. That's why this is called sea foam. When you have a D-link, of course, you have a normal map settings. You also have a foam slope influence, and this is responsible for texture stretching. You see that when the wave comes, it stretches the foam texture. Do not set these values too high, because you will get a stretched result. But this is very cool feature, because in fact, let's maybe improve it. Besides that, it may generate errors on the edge, that you get an effect that the foam becomes stretched because of the upcoming wave. So let's maybe turn off our refresh now. And you have of course foam normal texture, so you could change or just with sliders you could improve the normals of the foam textures. You have a foam multiply, so in fact how the waves interact with the foam. With bigger multiply, simply even lower waves will start to spawning the foam. You have a mask offset, so you could cut foam from specific wave height or just offset the effect. And you have a power, so this effect could be more sharp or soft. Like I said, we often use multiply and power functions together because we give you ability to achieve almost every kind of effect if these two sliders and values are together. Also, the foam could be spawned by tessellation, and it's not only about the tessellation, it's just a high map. So the tops of the high map could spawn the foam as well. Maybe let's multiply this effect. Maybe let's, okay, and let's multiply this effect. Okay, increase the power of the, now we have a high map which dominate the foam effect. You see? So the high map of the water, which is used for tessellation, may spawn the foam. So if you have if you bump the water body with tessellation, it also could spawn a foam in that place. Okay, so that's about the tessellation foam. Let's maybe hide this effect. At all. And let's go to the shoreline. For the shore foam, you have a side foam. You have a side foam depth, because you could manage how depth of the water will spawn the side foam effects. So the foams that are mostly visible on shoreline. You could multiply the depth, you could power, so follow of them. But you could manage the fall off and depth influence of the side foam effects. Of course, you have a mask for this foam, you have a mask power as well. So if you will, for example, reduce the power of the mask, you will get only noise, or if you will kick noise effect, you will just have a white color instead of the foam. Of course, you could decrease or increase the side foam speed, or change the flow map speed refresh. The same as the wave foam, sea foams, you have a slope influence, so how the foam becomes stretched by waves. You see? it's a bit also like maybe I set opposite value, but you may stretch or adjust this effect a bit. Of course, you have a T-link for form, the side form as it's separated from the C form because it have smaller granulation, right? And normal scale as well. But now there is a big difference between C and side form. First of all, with side form you could manage how much of the form is visible on the wave backs, but maybe for this setup I will back to our global demo. Let's move to the side form. Okay, so you could manage how the amount of the form on the waves back, right? And offset this value as well. You could set how the waves affect amount of foam, the side foam. So in fact, what you could change with that, if you will have a smaller waves like in the demo that I had before, if you will increase this value, the foam will start to appear on even on smaller waves. But if you have a bigger waves like here and you don't want to have a foam between them, you simply with waves multiply and offset could cut the foam from the area between waves. You have a multiply, offset and power function for this effect. And the another big difference is that you have a creased color, so the color only on the tops of the waves. Maybe okay, if I will reduce the, and of course you have a offset and multiply for this effect, but if when I reduce the offset, you see that you could set different color from the tops of the side foam effects from the rest of the foam. So maybe let's set up this too. Oh, you see now everything. You have a foam on the water body, the side foam, and the crest, so only the tops of the waves could have a different color, or just simply you could increase the brightness of these parts, right? Because the intention is to increase the color of the foam on the tops. Yeah, and also you have a creased mask multiply, and you had the mask power for the foam here, but you could multiply it only on the crest. So for example, you have a granulation on the on this foam, on the lower part of the foam, but the top of the foam will be super bright and will have no gaps from the noises. So you could just increase the decrease the or manage the mask multiply, right? Of course, for the foam you have a purling T-link, so you could simply break the T-link of the foam, right? Maybe let's multiply that power. You could see that you could simply kill the foam T-link with this purling noise. Okay, so that's all about the foam. Now we have a tessellation or simply offset values for water, which comes from the texture, because the tessellation at tessellate shader will be tessellation, at the offset shader it will simply bump the triangles up. And this is a pretty cool feature, because mostly for offset shader, because you may notice that if you don't use the offset shader, but you have a density of the mesh of the water body is high enough, it will behave exactly the same like it becomes tessellated. So if you will bump the waves by texture, if you have enough density on the water body, you will get almost the same effect like with tessellation. So you could simply bump the water water body from water small waves. And you have the same situation with, because this water tessellation comes from water tessellation texture, and this tessellation have the same tilling as water normal, because it must have. It's basically the same texture, but this is normal map, but this is high map from the same texture. So you have a basic normal offset, the scale, and the macro wave scale as well, like in macro wave normals. We didn't place microwave tessellation because it will simply only noise the water body. Here you have a translucency effect, so you could change the translucency on the globally, or only directly when you look at the, let's maybe use the global power and increase the direct sun effect. So when you look into sun direction, you could set up translucency for microwaves, so the small waves, or for these bigger tessellate waves as well. So this high map is not only used for bump the water body, but also it could influence, as it bump the water body, besides that it could influence translucency as well. You have a multiply and power functions for that, right? It's visible here because this comes from the high map, and you could simply manage that. So beside the translucency, which is bumped by the waves, the bigger wave stripes, you could also bump microwaves as well, just to get additional, I would say, noisy effect on the translucency. Okay. About the bigger waves, you have a effect of translucency. I would say we separate the front and the back part of the wave, because in fact in most cases, besides that, you could increase or decrease translucency on the waves as they are, right? You have a power functions as well. You also have a front wave power or multiply, just because mostly if you look on the front of the wave, probably it will be mostly visible exactly like right here. If you look on this front part of the wave, it mostly become more translucent. So you could improve this effect of highlight of the wave highlight if it's a front part of the wave, right? You could also increase the shoreline translucency. You could increase the translucency on the water that is pretty is not deep, right? And of course you have a translucency for foam as well. So you could set separated translucency power on the foam at the water body. You have a caustic effect, and this effect should be set up during play mode, because without play mode you don't have noises. And animated texture, so you have a tiling for caustic. You have a triplanar hardness, because tiling is triplanar, so it also appear on the vertical bodies. So you could set up triplanar effect on it. Of course, speed and fall off, so everything that will help you to achieve nice caustic effect, because maybe you want less bright effect, or with less fall off on the texture. It depends which texture you will put. If you will put our texture, we set up it pretty correctly, but if you will change our texture to any other, you will be able to change its fall off and so on. The thing is that this texture is a color texture. It's RGB texture. And about the material is almost everything. Besides that, you have a time offset, which is debug mode, just to move the waves and test some effects, right? Without play mode and always refresh mode. Okay, so that's all about the material, the C material. It's pretty complex, but it has multiple options. Sometimes I think that I should hide a lot of these options and make it more simply for you, but without that you will be not able to adjust everything to your goals. And I think the best way is to give you everything and explain what you should touch or not and when, and with that you will be able to get all results. And that's all for this tutorial, I think. If you have any questions, you have our Discord or email, and you could always ask about every aspect of this system. Bye.